some programming languages, you are allowed to have multiple ancestors. However, in Java, you cannot do this for classes, but you are allowed to for interfaces. Simulations are often used to imitate real-world systems. Weather, the stock market, and traffic patterns are just a few of the ways you can use simulations to predict the outcome of much larger or more complex systems. Since simulators cannot be nearly as complex as the original system, they usually rely on the simplification of one or more parts. While greater detail has the potential to provide greater accuracy, the resources and time required are the two most limiting factors. Consider tornado forecasting. While not exact, getting the notification out is more important than if the tornado actually touched down. Different things can be simplified depending on what is the most important part of your outcome. The benefits of using simulators is evident when you consider that they are safer, cheaper, and quicker than using supercomputers to process that much data. Our example in this chapter is the predator-prey simulation project using foxes and rabbits. There is often an ecological balance that must be maintained in order to keep the predators fed and keep the reproduction at a steady enough rate to replenish the supply. Too many predators, they eat all the prey. Then the predators die from starvation. Too much prey, and then the prey starve from overpopulation. Looking at the rabbit class, we see several configuration settings that determine when they reproduce and when they try to move, etc. One of the main simplifications is the gender of the rabbit. There are not males and females. A rabbit could potentially give birth every step, once it is of correct age, and all rabbits die at the same age. The fox class adds a hunger indicator, food level, and hunt, where they must search for food, breed more foxes, die of old age, or die of hunger. As you step through the simulation, it is evident that you could add inheritance to the foxes and rabbits by creating a superclass animal. Many fields and methods are shared between both foxes and rabbits, and combining them into the animal superclass cuts down on code duplication, as well as makes code changes easier. Open the simulation and run it. Characteristics of a rabbit. The rabbit's behavior is managed from the run method. Age is incremented at each step in the simulation. Rabbits can breed at each step, after the correct age. Rabbit simplifications. Gender is not specified, all are female. The same rabbit can reproduce every step. All rabbits die at exactly the same age. Characteristics of a fox. The fox's behavior is managed from the hunt method. Foxes age and breed. Foxes become hungry. Rabbits did not. They hunt for food in adjacent locations. Fox simplifications. Gender is not specified, all are female. The same fox can reproduce every step. All foxes die at exactly the same age. The simulator class. This class creates animals of various ages with the populate method. Simulate one step iterates over both populations separately using field and updated field. There are several areas that we could improve upon, one being the rabbits and foxes do not share a common superclass, but they do behave in similar ways. Another that is that the update step is very similar for both rabbits and foxes, and the simulator class is tightly coupled to specific classes.